I just want to thank you guys again for taking the time to come out and spend your evening with us and getting away from parent-teacher conferences to, like I said, to come spend your evening with us. But with that being said, we have some other things going on at the association. One of those being our town hall series, which actually begins right after this at 6:30. What this is our town hall conversation on race. It's a very exciting town hall series that we've been doing the last month or so. And I think you guys would really enjoy it. And that link to that event should be in the chat coming soon. On top of that as well, keep in mind, this is engineering week. So just keep your eyes open for the next coming weeks for the other colleges, and we'll be doing events very similar to this. Now, with that being said, I think it's time to turn it over to our Civil Engineering Society President, Timely Frierson.
Thanks, Brock. Hi, everyone. I, along with the other board members, Katie, Joseph, and Marvell, would like to welcome you to this virtual happy hour. Thank you all for joining. I encourage you to become an active member of the society. And if you're interested in becoming a board member, there's an opportunity for you to submit your interest. A link will be provided for you in the chat. And we would love to have some fresh new perspectives. So again, if you are interested, complete the form. So for the board members, we currently hold at least two board meetings, per year, mainly via conference call, and we do at least 2 events per year. Some of the reasons to join the Engineering Alumni Society: networking, you can meet new people, make connections, build relationships via Cveg Alumni Society, social media sites, and alumni events throughout the year. Service and support, give back to the Civil Engineering Society community by volunteering and sponsoring events. Career service, whether you're making a career change, positioning yourself for the next promotion, or looking to hire for your own companies. Emails about job postings and postings on alumni social media sites can be very beneficial. Stay connected. Once a Razorback, always a Razorback. So you can show your pride in any part of the world by staying connected to the U of A through the Cveg Alumni Society. Civil Engineering Razorback News. We receive important updates of U of A civil engineering achievements, alumni accomplishments, and news and sports information. So just think about it. The links will be provided in the chat pod for you to become a member, or if you are interested in becoming a board member. Also, if you're still connected to other Cveg alumni, please encourage them to join the society as well. Again, thanks for taking the time to join this happy hour event, and be on the lookout for future virtual events. So I'll now turn it over to Cveg Alumni Society board member Katie Story. Katie is a 2007 Cveg graduate and currently a project manager for WNW AFCO Steel. Katie will introduce our virtual tour guide for this happy hour event. Katie, the mic is yours.
Thanks, Timely. Like she said, I am a graduate of the U of A, graduated in 2017, and I work for WW AFCO Steel here in Little Rock. That is where I first heard about this CEREC project as we were fabricating steel for it. And Timely and I and the rest of the board had a meeting one day, and we were talking about what kind of virtual events could we have, and that immediately popped into my head to have some sort of tour or something similar, as I know I was interested to see what was going on inside. So I thought others might be as well. And so we kind of helped put this together, and Dr. Prinz has really been a great help, and he's really taken the reins and done really great. So I wanted to, before we turn over to Dr. Prinz himself, I wanted to say during the tour, it is a pre-recorded tour. If you have any questions, put it in the chat and we will go over that afterwards. And if you have any questions during the Q&A, just put them in the chat as well. So over to you, Dr. Prinz.
Yeah, I think Mercedes has a video she's got all pulled up. She can just play if she's still on. All right, here we are at the Civil Engineering Research and Education Center. Behind me, this is a new large-scale structural testing facility for the Department of Civil Engineering. Here we're just right in front of it, kind of the front view of what we have now with the exterior, and we're gonna head inside. We picked a nice clear weather day to do this. Here we're gonna walk over here into the front lobby area. You see over here to the right we have the stairs and the clear translucent panels that'll shine the light from inside the high bay. This box right here, inside that box, is our hydraulic power unit that's going to provide all the power to the equipment on the strong floor. We're going to walk around this big puddle here and head on inside the building. Here we are inside the main lobby. We have the two-story atrium. Behind us on the upper floor will be a student working space, student offices. Down here is our student maker space for like the concrete canoes, steel bridge students to work. Behind us over here, I'm just going to point out, is some other office type rooms. And then we're going to head over here into the strong floor. So come on in here. Here we have our strong floor with the steel embeds. Now they've got, if you come close, we can take a look. There's 216 of these embeds and 3 layers of a rebar mat. So we have a lower, a middle, and an upper rebar mat. And all of the rebar are number 9 bars, so they're 1.8 inches in diameter. And these embeds that you see here that they're walking on, they've all been laser leveled and made sure that they're nice and flat. Above us over here is our 25-ton crane. It's going to allow us to maneuver large test objects on the strong floor itself. The strong floor embeds, the interior embed here, has a capacity of 240,000 pounds for pull-out and 220,000 pounds for shear. Over here behind us, you'll see it's not going to be framed in, but we'll have overhead lighting for a fabrication space for welding and machining. As well as on the other end, we have another fabrication space down there. If you walk with me, we'll walk around the strong floor here and go into the concrete materials room. It's just off the high bay here. This is where the concrete materials group will be doing their research. We'll have a climate chamber. This is a really nice space with an overhead door so they can provide access for their aggregates and other things that they need for mixing their concrete. They've already started putting the drywall up. We have power and other things in different outlets. Let's walk this way. Here, which is just north of the high bay, this will be our material testing room. This is where a lot of our material scale testing will be done. This room will be climate controlled and stay rather clean relative to the concrete and the high bay. In here, oh, this is like a metallurgy, excuse me. That's like a metallurgy room where we do a lot of the fine scale material investigation. And here is our materials testing room. It's a little bit bigger, but we have a lot of our existing material testing equipment will go in here to allow us to test things from the material level to the component level and then the very large scale structural system level on the high bay. Let's walk quickly through this. This room won't be here. This is not a door, but we're going to go through it anyway. These are like bathrooms and PPE rooms where we can have equipment for like clothing and hard hats and stuff that we need for doing our work. And in here, in this room, this is where our large hydraulic power unit goes. You can see the trench that's dug to allow the hydraulic power to go in between the strong floor and the concrete slab. There'll be a trench there to where it'll go to our manifolds that will be stationed along the strong floor so that we can hook up our hydraulic actuators and do our large scale testing on the floor. And then back in here, I'll just show you. This is where we have a lot of our, well, they moved some of it around, but this is where we have a lot of our compressed air and high pressure air systems that will help provide different services for the different rooms. Let's go take another look at the strong floor real quick from another angle. Let's walk out this way. Can't go that way. Well, we've made it through. We're back here to the high bay, and you can get a good picture by looking back down there of what the room and the capabilities will be like as far as space goes. Again, the in-beds here, the finished floor height will be flush with that steel plate. So you'll see just a bunch of steel diamonds. They look like they're flat with the floor, but there's about 3.5 feet of concrete and rebar underneath each of those in-beds. That's going to allow us to get our structural capacity so that we can test really large things. So this is our new Civil Engineering Research and Education Center. It's going to be really a transformative building for Civil Engineering Department and for the state of Arkansas, really, to allow us to do very large-scale, important research that needs to be done to advance the state of the art in structural engineering.
If anyone has any questions, I'd be happy to answer following that. If there's any more information I could provide, I know it seemed a little choppy, probably from the streaming, but.
What's the total square footage for the lab, Gary?
Oh, that's a good question. I don't know the exact, I don't know the number. If I remember right, I think it's like,
I think it's about 37,000 square feet at one point, I think.
I was thinking it was in the high 20s, but that could be closer.
Okay.
It's changed several times as we've gone through different phases.
I do know it's got 424 tons of structural steel in it.
Just, the floor's got a lot of that, right?
5 tons are in the strong floor embeds.
And all that steel is beautiful.
Yeah, it looks pretty good. I was joking with Grady the other day that it's a concrete reinforced steel floor. They will be pouring the concrete on I've heard the midnight on the 10th of November. So I'm going to head out there. I'll take some more pictures and I'll update the alumni with pictures of the concrete pour. It'll be pretty interesting.
You probably won't have a whole lot of supervision out there at the beginning of the pour.
Yeah, I don't know. It's going to be interesting.
So Gary, you mentioned the materials lab. What labs, are other labs moving over to this center from the research center when this is completed?
Yeah, so total move over. My materials lab will be completely moving over. Some of the other stuff, because we currently at the research center now, we kind of share space with CTTP, which is our Center for Training Transportation Professionals. So some of that equipment needs to stay to service CTTP's mission. But yeah, I would say most of the core like materials research that we do now is moving over to CEREC, with the exception of some of the concrete stuff that they do at CTTP.
Is Civil going to lose that lab space in the other building, or are they going to be able to repurpose it for other uses?
So part of the agreement with the college, because the college helped fund some of what we're doing, the space that I'm currently occupying with my lab will be turned back over to the college. But the other stuff on the concrete material side that we have now will remain for CTTP until a later phase of the project, if we can build out the CTTP structures out at the CEREC site. That's right. Any other questions?
Has there been any talk about trying to move forward with the project to put it the second floor student offices?
So if Mike is still on, I don't know if he's still on there. That is the goal. The goal is to finish out that second floor, the student offices. Micah knows more on where we stand related to funding that than I do. But I think Micah, that's one of Micah's really big goals, is to make sure that that space up there is usable and accessible for students. because currently as it is right now in the project phase, like it's not finished out.
Yeah, then they're not even putting an elevator in, right?
That's right. Because there's no access, there's not going to be an elevator put in. That'll be part of the cost of that second floor finish out. That's right. Any other questions? Curiosities about how big of things we could break?
How many research projects do you have lined up that you can work on in the new facility, Gary?
So I have one right now that I'm waiting on for the lab to be built, and another one that will be starting here probably pretty soon. So, and then I know Dr. Murray has a project that he can use the lab with, so we'll have probably 3 right away that'll be going. The one that I need is my seismic. It's a seismic steel connection study where we're doing full scale seismic component testing for the American Institute of Steel Construction, and that testing will be the first sort of testing that we set up in there.
Okay.
You mentioned
we're just waiting. What's up, Katie?
You mentioned that there's like 2 fab areas. What kind of fabrication or like what kind of scale of fabrication do y'all expect to do?
Yeah, so to support the research that's going on the strong floor, say, various fixtures and other things will need to be fabricated. So over there in those areas, there's some pretty large lathes. There's going to be a mill and some welding equipment. The welding equipment, I think, will be fairly mobile, so we could pull it out onto the strong floor and do in-place welding if we have to for our fixtures. But it'll basically be, machining equipment to support the goings on the strong floor for fabricating the fixtures and so forth. Because a lot of the stuff we do, it's really like custom work, and to get the things to attach right and to work, we need to be able to fabricate custom pieces.
So Gary, talk a little bit about that, if you would. I just recently heard that most of the welding are going to be done by students under your direction, but I know welding is a pretty important part of structural makeup. How are you going to make sure you have good welds on your testing?
Yeah, that's a good question. It depends. I would say it depends on what the welds are used for. So if the welds are just for a fixture that's a key element in the load path, perhaps that actually needs to be structurally welded by a licensed welder. If, on the other hand, it's, because sometimes in our experiments, we need to just attach something to something else to mount some sort of measuring device, or we're welding a component that might be key for the experiment, but not taking a lot of load, like say a transverse support for preventing local buckling during a test. All that stuff can be done by the students. And, as the students get their hands dirty and they get to practice, they just get, that's just extra experiences for the students, in my opinion. I learned to weld in a structures lab. So I'm not a certified structural welder, though I understand my limitations. And so, like I said, key things, sure, we need to send those out. If they're actually part of the specimen itself, that's part of the, let's say it's an important actual component that we're testing, that's going to be done by a professional. But the other fixtures and other things like that, students are going to be all part of that. Same with the machining and the mill work and the lathe work, that's going to be run by students. Obviously, students that are trained by our existing staff, and there'll be probably a whole process for that. But, getting to work in a big lab, that's all part of the experience, I think.
Hey, Gary, it's me, John. I'm make sure you know I'm on the call.
Hey, Dean.
Hey, cool stuff, man. Cool stuff.
Yeah, it's gonna be great. Thanks for all the support from the college and from all the alumni and everything. It's a big deal.
Yep.
So Micah's back on the call. Micah, you back?
He's still logged in. He might be
checking
about test scores. This for students.
Yeah, still off.
He may be talking to Norm. We just got a third briefing of the ABET team, and we're just answering questions and trying to clean up the reports to as good as possible. So, yeah, because there was a couple things he wanted to talk to Mike about. I don't know, because Norm's also tried to call me. So.
Gary, I was impressed with the amount of people that the contractor had working out there. Can you talk a little bit about the schedule?
Yeah, so the schedule, we're actually a little ahead of schedule. I don't know if you remember from some earlier updates that we had provided kind of over the summertime. The strong floor concrete pour was really scheduled to happen after the first week of December. But the contractor was really kind of holding some contingencies for the placement of those embeds in the strong floor, getting that kind of process pretty well figured out. And they had budgeted some time for that, but that went fairly smoothly. And we've had several meetings out there and everything looks really good. And so there, there's always contingencies for other phases of the project built in, but I think they're a little ahead of schedule right now. They had, when I was out there a couple days ago, I think the concrete folks that are placing the rebar, they had like 30 people out there working on that strong floor. So it was quite a big push, which is awesome to see. And of course, we're excited if we can get in sooner because we got a lot of big steel and concrete pieces to break. A lot of interesting things to find out. Oh, there's Micah.
You might have mentioned it earlier, but who's the contractor on the site?
CDI is the contractor for the project. And Matt, I see Matt's down there. He could perhaps comment more on schedule if he's aware of it.
Gary, did you tell him we're going to get in a month early? Is that right?
I said 3 months early.
I
think Matt had promised that. No,
the strong floor is getting poured a few weeks early. All that pushes everything. I think it's a June or a May 1st opening.
Yeah, and there might be some other things that there's contingencies built in for other, construction phases. So I'm not exactly sure how the final, key turnover date will be, but things are really looking good. I'll tell you what, they were, when I went out there the other day, they were placing those strong floor end beds. They were laser leveling every one of them and measuring like 4 different locations on the embeds themselves before they would secure the nuts on the bottom. So those are, and each one of those embeds weighs 1,000 pounds. So they're maneuvering these things and getting them very well. You can see from the video how precise things look. And I'll point this out too. We had several meetings with the concrete contractor or subcontractor, and the finish that they're going to provide on the floor, because of the spacing of the embeds, the gap between them is actually not that large, and they're going to end up doing a lot of finish work by hand. It's going to be quite the process.
Gary, they were talking to us about the concrete the other day, and it's a special concrete with pea gravel in the concrete, and so it'll flow through the rebars better. And it's 5,000 pound concrete.
That's right. It's 5,000 pound concrete. I know it has smaller aggregates, and it has a pretty high proportion of fly ash to keep the temperature cooler as it's curing. So because it's so thick, I think it has, if I remember right, I could be wrong, but I think it has about 40% fly ash to help keep the temperature a little bit cooler so they don't get it curing too fast.
Good.
And they're gonna, I'll point out too, they're gonna, I can't remember who it is, but they're instrumenting some sections of the strong floor to monitor the temperature during the pour. So everything's going to be very well kind of controlled during that process. And they're really, I'll tell you, the contractor is really taking their time and making sure it's a one-time shot, right? You see how much steel is in that thing. You're not getting that up easy. It's a one-time shot. So they're taking their time and they're being very careful on that whole process to make sure that everything goes smoothly and correctly. So we can have what we need to have as an end product to really, do some pretty crazy things later.
Yeah, just one thing I'll add to Gary's, since he's also a concrete expert. So they're using self-consolidating concrete. And so GCC is doing it. And what it is, they flip-flop the rock and sand content. So generally you'd have about 1,700 pounds of rock and about 1,100 pounds or 1,200 pounds of sand in the mix. So they flip those. And so now you've got 1,100 or 1,200 pounds of rock and 1,700 pounds of sand. So it keeps the mixture more cohesive. And so they use the small rocks because of one, just they don't have that much space in between the rebar. And then the fly ash not only keeps the heat down, but it gives us more paste. So it's more like a thickening agent in a way. So the concrete doesn't segregate whenever they pour it. So they don't pour a slump on it. It's called a spread. So when they test it, they'll see how far it spreads out. So it'll spread about 24 or 25 inches whenever they test it. So it's an equivalent of, if it's 1/2 inch pea gravel, it's going to be an 11.5 inch slump. But they basically measure a spread on it. So that way they can pour from two ends and it can be all stay fluid and won't have any cold joints in it. But that's all the concrete talk I got.
You might add is also setting on top of drilled shafts or drilled piers.
Yep. Yeah, there are several piers throughout, one at each corner and several throughout that they had to weave the rebar through and maneuver those in beds next to.
So you got geotechnical and steel and concrete all in the same.
Yeah, it's big. It's a full civil project. And we got a road that's going in right next to it too. They had to put in, so it's transportation.
Just make sure it drains.
Yeah.
Is it structurally connected to the building or completely separate inside the shell?
So it's not. I mean, it's not like the footings of the exterior building aren't connected to the strong floor. There will be a slab poured up to it, but that'll be poured after itself. The strong floor itself, the way that it functions, it's all loads that are provided to the strong floor by the testing that we do on top. It's a self-reacting system. So anytime we're pulling down on a specimen, we're pulling up on the floor and also pushing down on the floor equally. So the floor itself, as far as the soil underneath the floor, does not feel necessarily the loads that we're applying to the specimens, if that makes sense. It's almost like we have a giant beam that we're just reacting against by pushing down and pulling up on it.
Wow.
You might also mention that the contractor's got a couple of cameras set up so you can actually time lapse what's been done to get to where we are today. It's pretty impressive.
Yeah, so we have two, I think they're called Ox Blue cameras. The one set up on the exterior, kind of facing the south side of the front entrance of the building, watching that construction go. And then the other is inside, and they put that one in there prior to them excavating out the interior soil for the strong floor. So we're still waiting for all that stuff. There's a time lapse that we'll produce from that, and we'll be able to send that out to everyone, all the alumni. It's pretty cool.
Gary, when will you start teaching in the building?
So if it's going to be, I guess the first steel class that I will teach will be fall of next year that we'll be able to be in there.
Okay.
So, and it's actually perfect timing because we're doing our seismic steel connection testing. We'll be able to take them in there and show them, you know, I don't know what a W36 by looks like physically, and then how much force it takes to put that through some very large inelastic displacements. So they'll get some hands-on experience next fall.
Well, that's exciting to get started.
Yeah, it's really very exciting. Any other questions? We can send out that link. I think Mercedes already posted it in the comments, but we can send out that link to everyone if you all want to watch it a little bit smoother. Maybe we won't get motion sick.
Hey, Gary, since you're talking about steel design and you teach steel, I want to take this opportunity. I think John Withrow is on the call with us. John is the general manager and vice president, Nucor Yamato, up in Blytheville. He's new up there. This is his first 2 or 3 months here in Arkansas. So Nucor Yamato furnished us the main building. So wanted to introduce him to the group. I don't think you guys have met him. So I'm glad for Nucor Yamato there.
Yeah, thank you very much, Nucor. Appreciate it, John.
Oh, thank you, and thank you, Grady. It's pretty exciting to see the investment in the future for the university, for the students, and in hearing what's going to be testing the steel. You mentioned some pretty large sections there, so I look forward to seeing maybe in person or at least a video clip sometime of twisting and manipulating some of these heavy structural sections. That's pretty amazing what you're going to do there. And I'm sitting here thinking about some of the projects that I've seen, and just that floor, the strong floor is an amazing feat itself. So look forward to learning more about the future and what you're testing up there.
Yeah, we'll be sure to share it. And, you know, steel is very strong, so it takes a lot of force and it takes a very strong floor to be able to break it, right?
Yeah. Well, that's the other thing. You're going to be looking for research funds, and American Institute of Steel Construction does a lot of research, and hopefully you'll be able to win a lot more research projects with a facility you have now than what you've been able to in the past. So,
yeah, that's a good point. Like a lot of funding agencies for large civil engineering type of research, they like experimental verification of performance. Say like before AISC will change the specifications to allow a specific seismic connection, for example, or other special steel detail to be allowed in their specifications. They like experimental verification. And so labs like this are required really to be able to provide that. And now Arkansas will be competitive for that research.
I'll give you an example. I think we have some RDOT folks on the call with us, and one of the, just intuitively for the years when I walk through the shop, I would think that we've had more shear studs on the top of steel girders than what we really needed to carry the loads. So we funded an initial research with Gary back in 2015 to do shear stud research.
Yeah.
And to give everyone on the call a little bit of an idea of how long it takes to get a code changed. And it's not a bad thing that it takes the research to do it, but you might go through the time frame from 2015 to when you might actually get the research done and presented and get it into the code to change the design criteria, which will save a lot of money on shear studs by elimination of them. So the research that's done here saves the taxpayer, will save taxpayers money down the road too. And I want to point that out because I think the highway department or the RDOT's caught a little bit of flack about putting in some money into this research facility. And I want to point out that it will get a payback to the taxpayers for the research it's done. So you might comment on that.
Yeah, and you know, so our shear stud research, we had a PhD student graduate in that time frame, attended a lot of AASHTO meetings, presented the research about over a dozen times. And, you know, we're to the point where we are drafting revisions to the code and people will be voting on things. COVID era is a little bit weird. We didn't really meet in person in our last January or our August meeting. But yeah, it's getting to the point where the work that we've done here at Arkansas is going to be implemented into the federal bridge specifications shortly, I imagine. And you know, that translates to improved economy for our our infrastructure that will be built here on out. And you know, a good point about savings and taxpayer dollars, it's not, you know, a lot of the investments that are made at the state level don't just affect also the state economy. These are changes that are made nationally. So they are much larger than you might think. So it's not just bridges in Arkansas, it'd be bridges in everywhere. So, you know, the savings are there. And, you know, a lot of that research that Grady's talking about and getting those things through that sort of a difficult process. It really is a difficult process to convince people to change something that's been there for 60 years. It takes a lot of experimental testing. And, you know, the facilities like the ones we just walked through in the video, CEREC, they're just at a different scale to allow those sorts of things to be understood better.
Hey, Gary, where is the closest comparable strong floor lab to Fayetteville, or I guess Arkansas?
So there's a lab with a significant strong floor and strong wall up at KU. I think K-State has one as well. John English knows about that one. I think he championed that one being constructed. There's one, UT Austin has one that's quite a bit older, of a different sort of configuration than the one you saw in the video. They are sprinkled around the country. The capacities of them differ and the functionalities will differ from their configuration. The one we have built here at Arkansas is a fairly flexible strong floor. We have built it almost like a Lego board to where we can attach various columns and fixtures to test very complex systems in multiple ways. So it's a little bit less restrictive than some of the other existing labs around. KU is an example where, you know, the way they have to connect to their strong floor is a little bit more cumbersome. So it makes it slightly more difficult in some situations to do it. Oklahoma State, I forgot about them. They have a pretty good strong floor and testing facility now as well. I will point out, just this is just a plug for my colleagues here in the Civil Engineering Department. The infrastructure and the lab that you saw in the video is just one component, right? It's a tool. It's like a tool for a craftsman, right? It still requires the craftsman to use it. And so here in Arkansas, we have very good faculty, Dr. Murray, Dr. Heimsfeld, Salvam, Hale, to really think of very useful and interesting things to research there. So you have the facility, but you also need the other side of that coin, which is the manpower and the people to make it really productive. So I fully expect it's going to be a greatly used facility here.
So to kind of follow up on what Gary said, so I came here in, I guess, 2002, and Steve Payton's on the line. He's was one of my first grad students, one of the second, within first or second groups. But anyway, we built an outdoor pre-stressing bed. It's still there, and it's attached to the strong floor that we had, and we probably cast, I don't know, 120 beams on that, using that bed, and AFCO provided the steel for the abutments and everything. But anyway, so over time, the pre-stressing bed, the strong floor that we had that we anchored against, now has about 1 inch wide cracks in it due to some thermal cracking and everything just being outside for the last, I don't know, the strong floor was here when I got here, but I texted Steve during the presentation. I was like, this looks a little bit different than what you and Jamie Wilhite and Blake Staten and a bunch of other guys built about, 15 years ago. So it's definitely, it's miles and miles and miles improvement of what we've had over the past, 50, 60 years. So,
yeah, we were.
Well, go ahead, Steve.
I was just going to say, we just added, for Blake's project, we just added ends to that existing beam that was there for the old precast bridge unit testing that Dr. Heimsfeld had done when he first came, for the ones that didn't have shear stirrups in them. So, it's been cobbled onto a couple of times, and to see something purpose-built like this is, and even all the things that we did were in the back of a old pantyhose factory, or whatever it was to begin with, that building. And so to see something purpose-built for civil engineering like this is just really inspiring, I think, to me. So.
Yeah, the opportunities that Gary and Cameron and the future faculty have as far as structures work are limitless. I mean, they're all creative, and now they've got the facility to do whatever their minds can imagine. So we are very thankful for the support of everybody for that building.
And at some level, it's almost a good thing that we didn't always have this, I guess, because we come from an environment where we had to be creative before, right? So we developed certain skills in this existing research infrastructure that we have, that now when we go into the CEREC, the creativity coupled with the resource will make us even probably more productive then. And our ideas might be slightly different than, let's say, our counterparts at other universities.
We might comment a little bit about the design of the strong floor. And John English and Jim McClellan and I went to Kansas State. They have not only a strong floor, but they have a strong wall, and which is a vertical system similar to the floor. So you could actually have a structure tied to the wall. And that would cost us in the neighborhood of $1 million to $1.5 million more was the initial budget. And we challenged Gary, instead of having a strong wall, we would figure out how to use just a strong floor to be able to test in both dimensions and to eliminate that additional cost that we were trying to save. And so that's the innovation, that part of the innovation that Gary's talking about. And we were able to bring it in at a lower budget than we would have had if we had built it like Kansas State. So,
yeah, the way we designed our strong floor, each one of those embeds is capable of attaching a column to it, and each one of those embeds on the interior can handle 240,000 pounds. And so by spacing various columns and building, let's say, like a vertical truss, we can essentially construct a strong wall on the existing strong floor by occupying a little bit of the floor area. But the strong wall is not always there. When we don't need it, we can disassemble those. I call them Lego pieces. They're giant steel pieces, but we can disassemble them and reassemble them when needed, so we don't occupy that sort of space like Grady was talking about.
Back to the question earlier about the different universities with the research facilities. It's interesting. We need to point out that Arkansas is, without this research facility, we would become less competitive in the SEC. I think 9 of our SEC universities already have a research facility similar to this. So we have to have this to stay competitive in the state of Arkansas with our civil engineering program. And that was one of the key factors we were pushing for this project. So.
Yeah. Any other questions?
I'll have one thing. For any of y'all who want a tour of the lab, let us know. Gary and I are happy to give anybody a tour of the lab anytime. CDI has been great to work with. We emailed Josh and say, hey, Josh, can we bring out some visitors? He's always very happy and willing to let us walk around, folks. So Jim and Bert came out last week and we gave them a tour. So anybody wanting to come out, feel free to send us an email, and we are happy to arrange a tour for you all.
Micah, are you going to live stream that midnight concrete pour for us? You can give us the play-by-play as it goes through.
Well, fortunately, Mike Johnson and FAMA, they've got a live stream up. And so I can send out the link. And so you can watch them pour it at November the 11th at, I think, 1 o'clock they're gonna start. So one of my old students, Remington Reed, is going to be one of the concrete folks, and Lance Hellinger. And then I don't know if you remember, Steve, Tom Green, he spoke to your class, maybe. He's a Grace admixtures guy. And so he's going to come up and they're going to help place the concrete because it's a significant pour. I mean, there's going to be a lot of heat generated. So they're bringing him in as kind of a technical consult. So it'll be a really neat thing.
Hey, Micah, you're not going to tell everybody this is phase 1 of a 3-phase project for civil engineering research, right? John, you're bailing on us. You're getting out of the dean's job for a year or so.
Let's go, Grady. Let's go. But it has been a wonderful.
We've got the transportation center. We're going to wind up down there at the end of the day, right? Isn't that the goal?
Mm-hmm. That's right,
Micah.
Yeah, that is the goal. And so since John's in his new role, I'm sure he can get us more money because when we move out of the pantyhose factory, we're going to free up a ton of space that John can use for startup for all the new faculty he's hiring. So that's the ultimate plan, is to move the whole footprint of civil engineering into the structures lab. They're going to add a couple more labs, move the Center for Training Transportation Professionals out. That's going to free up, I don't know, 15-ish thousand square feet out of the pantyhose factory that John can then parcel up for new hires. So no, it'll be great. And this is by far the most expensive phase of it. The other phases won't be near the cost of as this was.
Now, I've said for a long time, civil engineers only make the news when there's a structural failure. So we need to try to figure out how to make the news in a more positive way here.
That's true.
We'll make sure, well, Kim will make sure that the news gets out on that, and Nick will be all over this working with Civil, because we'll try to make it we got pretty good press on the groundbreaking too, though. I mean, we had, did the governor come?
Senator Bozeman.
Senator Bozeman. Okay, I knew some big guy had come, and yeah, so I'm sure we can pull that off again. And don't forget to invite me, okay? You know, I didn't die or move. I still live here in Arkansas, right? Yeah.
Well, it sounds like we've got most of everyone's questions answered. So I think this would be a good place to end it. Thanks everyone for attending and asking all the great questions. And thanks Dr. Prinz for heading this up and doing the tour. So thanks everyone.